Is nuclear energy still the way of the future? In the long run, nuclear power will certainly play a far bigger role than fossil fuels. We have enough uranium and thorium on Earth to fuel us for 1 million years, assuming our energy consumption doesn't grow beyond current trends. Each ton of uranium or thorium contains the nuclear potential to produce 1 GW year worth of electricity or 25 GW year worth of heat. That means just 5,000 tons of uranium or thorium have enough energy to fully power the entire world, including electricity, heating, process heat and transportation. For a full year, known recoverable uranium reserves stand at some 5 million tons, 1,000 years at current consumption. That assuming current uranium prices, the higher the price, the more recoverable, really economical, uranium we would be able to mine. The oceans contain billions of tons of uranium, and we already have the technology to extract it if uranium prices were to rise fivefold. Thorium has a substantial mining cost advantage cause most thorium comes mixed with lanthanides, rare earths, which we need to mine anyways for electronics production. Thorium might be considered an almost zero cost byproduct. China has thousands of tons of separated thorium in large piles in the open due to its extensive, albeit very polluting, rare earth mining. The fact I'm hiding so far is we're using reactors that are picky about what types of uranium they use. They require enrichment, which forces us to throw away about 85% of mined uranium as depleted uranium, plus only extracts the energy of less than 1% of the total mined uranium. I'm assuming reactors able to fission at least 90% of mined uranium and thorium in my calculations. We already have the uranium variant reactor in operation, Russian BN600 and BN800, with plans for the BN1200. Those aren't research reactors, but first-of-a-kind commercial reactors, generating electricity. Today realize that raw uranium costs represent a very tiny share of the total operating costs of a reactor throughout its lifetime. If we just assumed raw uranium costs would rise, so that fuel ready-to-go costs were 50% raw uranium and 50% processing of raw uranium until we have usable fuel, then we could use seawater uranium economically anyhow. I never expect nuclear to replace hydroelectricity, geothermal. I also expect solar and wind to continue growing in production up to at least 1/3 of our total electricity production. That would leave around 50% of total electricity generation up to nuclear. If we completely stop using coal, natural gas and oil to generate electricity, and in the very long term nuclear share might further drop to less than 1/3 of total energy generation. That means with ocean uranium alone we might be able to power our civilization for many millions of years, and that doesn't include crushing rocks for its uranium and thorium content, worth many more millions of years worth of nuclear fuel. The fundamental issue about solar is it's great for utilization in equatorial and tropical areas, but almost useless for polar, and of only seasonal usage for temperate areas. In Germany, solar production is reduced by 90% from the sunniest day of the year to the least sunny day, assuming no snow frost on the panels, otherwise production could be zero. Wind also has issues. Unlike solar, which has good predictability, wind generation can drop to zero right when solar is also useless in many places. For instance, there was a week-long very low wind period right in the middle of winter in London, right when solar is also nearly useless. There's a big wind farm right outside London. French nuclear and UK fossil production saved that week, so if the UK hopes to ever fully stop generating electricity from fossil fuels, it must retain at least 50% generation from nuclear, plus hydro and biomass, to avoid depending on France, having surplus generation capacity, which it has today, but might not have in the long run. Even if the odds are 1 in a million, people will never accept the risk of electricity rationing at any period of the year.